The question often asked is, why do young women with low AMH can get abnormal embryos? So women, even though they are in 35 or 36 years with normal karyotype, which is having normal number of chromosomes, why do they get embryos at times which may be completely abnormal? Now let's go back to how the eggs divide. When the body makes eggs, it's ready for fertilization. The egg has to get rid of half its chromosomes. Think of it this. A regular egg has 46 chromosomes, 23 pairs, but the egg only needs 23 single chromosomes. So when the sperm adds its 23, the baby will have the right total of 46. The process of dividing chromosomes is called meiosis. That is surprisingly error-prone in humans, much more than it is in animals. So why do these errors happen even in younger women? There's a machine known as a spindle machine, which is unstable. Inside the egg, the tiny machine made up of fibers is called spindle. That grabs the chromosome and pulls them apart. In human eggs, this machine does not work very well. And here's the problem. The spindle takes a very long time to form and it's quite wobbly and unstable. It often makes incorrect corrections to the chromosomes, and that is again one of the reasons why you start seeing abnormality. About 17% of eggs from women aged 20 to 25 already have problems with the spindle and how it holds the chromosomes. Human eggs are missing an important motor protein called KIFC1 that helps to stabilize this machine. This glue breaks down and chromosomes need to stay connected by the special glue, proteins called as cohesins. Think of this in very simple terms. Think of this like rubber bands holding your chromosomes together, and the problem is that these proteins were put in place before a woman was born. They gradually wear out over time and aren't replaced. Even when in the mid-30s, some of this glue is already breaking down, and that's where you start seeing errors. When the glue gets weak, chromosomes start coming apart at the wrong time or get separated incorrectly at the wrong place. The safety check doesn't seem to work properly. We think that women go through this at various ages and at different times. The eggs have a safety system called as a spindle assembly checkpoint. It's supposed to stop the division process if the chromosomes aren't lined up correctly. Unfortunately, this safety system is very weak in eggs, especially during the second division. Even when chromosomes are misaligned, the egg continues dividing anyway, leading to eggs which are wrong number of chromosomes or embryos that are abnormal. So why is it that sometimes a very low AMH may make it worse? AMH tells you about how many eggs are left in a reserve. When AMH is low, it generally means that there are fewer eggs, but some studies show it's also linked to more chromosomal problems. How good is that? Those studies will say it's a touch and go, and some studies going either way. Research found that women with low AMH have fewer number of euploid embryos when compared to women at the same age, and that's probably because of a smaller number of embryos that are formed. So percentage-wise, when there may be less, the risk of having an abnormal embryo reduces. Exactly when low AMH produce 1 to 2 embryos, while women with a normal reserve will produce a larger number of embryos. Thus, women with diminished ovarian reserves had 24% reduced odds at the embryo being chromosomally normal, even after accounting for age. Basically, looked at from numbers. So even though in theory low AMH might just reflect quantity, but it seems that there's some link in extremely low AMH to a quality decline. The proteins and structures responsible for making good eggs may be declining faster in women with a low reserve. And what we do not know is that women with a low AMH, are they going through a faster aging process? This seems to be a change in the biology, and each egg has the same unstable spindle machinery. And in some cases, you see repeated abnormality in embryos. And this same safety checkpoints are also not present. And thus, it's only after doing multiple treatments where you get the possibility of getting a genetically normal embryo.